Okay, moving on, we're going to work on angle of depression. Again, angle between an observer's line of sight and a horizontal line, except this time we're going to be looking in this direction. This continues to be our transversal, and these are both, as marked, horizontal lines. So this here is the angle of depression. I'm going to abbreviate that. And what I want you to observe is, since these are parallel lines cut by a transversal, we have alternate interior angles. So your angle of depression is also congruent to the angle of elevation. And this will come into play to maybe help you set up your problems a little bit easier. So let's look at example 3. A skateboard ramp is 25 feet long with a vertical drop of 20 feet. We want to find the angle of depression from the top of the ramp to the bottom of the ramp. Now, notice that this is the entire length, 25. The top of the ramp is 10, so I'm going to drop a line down here. If this is 10 feet, this is also 10 feet, which means this length is 15 feet. And that's what we're going to use to solve for our angle of depression. I'm going to take advantage of the fact that the angle of depression is congruent to the angle of elevation. Why am I going to do that? Well, when I highlight what we're given this side of the ramp and this side of the ramp. Notice again, we have formed a right triangle where the pink side is 15 feet and the orange side is 20 feet. Again, we're looking at the two legs, which means we're going to be solving using tangent. So tangent of x equals the opposite over the adjacent, 20 over 15. Since we're solving for the angle, we're going to use our inverse function. X equals the inverse tangent of 20 over 15. And when we plug that in our calculator, we get x equals 53.1 degrees. Okay, so here's the chance where we took the fact that the angle of depression is congruent to the angle of elevation. Okay, example 4. At the top of a 100-foot tall building, Nathan watches the start of a parade at an angle of depression of 65 degrees. How far away is Nathan from the start of the parade? So if the parade is starting over here, let's do our building. Nathan is standing up here. This is the start of the parade. Okay, his angle of depression is here, which means it is equal to the angle of elevation here. We know the building is 100 feet tall. The angle of depression is 65 degrees, which means the angle of elevation is also 65 degrees. Now here's where you have to be careful. How far away is Nathan from the start of the parade? This is what we're looking for. The distance from Nathan to the start of the parade, that's what we're looking for. We're given the height of the building, which again we are assuming is perpendicular to the ground, and we have this angle. So the question is, what is involved, what trig ratio involves the hypotenuse and the side opposite the angle? And that would be sine. Sine of 65 degrees would be equal to the opposite side over the hypotenuse. So to get x out of the denominator, we multiply both sides by x. And then we divide both sides by sine of 65 degrees. And we get x equals 110.3 feet.